Welcome to Business Analytics Module 1, Topic 1. Today's topic would be Introduction to R. The learning objects for this session would be to understand why we would be using R, understanding installation of Revo R, installing RStudio desktop version, understanding the nitty-gritties of RStudio, setting up your working directory, installation of packages and libraries in RStudio, the Google page for R, and the top 8 packages that one should be knowing. Apart from this, we would be touching upon something like data mining in R with graphical user interfaces, and then with usage of some of the packages like Swirl, we will be understanding how would be using some of the tutorials in R. That would be the fun aspect, and this is what we would be doing today. Okay, now why are we talking about data overload, big data, right? So basically, if you see, shares traded on the US stock market on any average day is around roughly 7 billion. Data generated in one flight from New York to London, 10 terabytes. Now this what we are talking is just something which has been recorded last time. This would have almost crossed double of what we are seeing on the screen. Data is too large, too complex for conventional data tools to handle, capture, manipulate, analyze and predict, and that's why we are talking about the 4 V's of big data. Just to mention that what we are showing on the screen today is 3 V's, but in fact it has moved on to the 4 V's of big data: volume, variety, velocity and veracity of the data, that is the quality aspect. 90% of the data was generated in the last 2 years, and that is what is talking about the quantum of data. Obviously it has become huge, difficult to manage, a lot of value in it. That's why we need analytics. What is business analytics? Data on its own is useless, right? That's what we would term. How would we use historic data, do something about it so that it could help us into understanding future? Can we predict whether a plane might malfunction when it is on 30,000 feet? Can we understand much before when anything could happen? Like for example, a manufacturing plant developing a snag. Can we understand whether a person would default when he is actually applying for a loan from a bank? If we could do that by looking at our historic data, yes, we would be predictive in nature, and that is where business sees value in business analytics. It's about predicting by using your history. Can I look at your historic past and understand what can happen in future? And that's why business analytics is there. What are the key issues which business would try to resolve using analytics, right? So for instance, a bank might be interested in understanding how can we identify whether a customer might default, right? That's the risk aspect. A telecom company would be interested in understanding whether a customer would opt out of the services, for example, terminate the postpaid connection. A company which is into HR analysis might be interested in understanding which is the resource who is going to put down the papers in the next 2 months, right? Because we need to do resource planning. Now, till now it was only when an employee would put in his resignation, that's where we would understand. Analytics seeks to answer that question. Can we see this happening in future? So what are the things we can do about it? For instance, if it's a good resource, we can try to retain him, right? If it's not that good resource, we can try to churn that resource much before he takes that decision, right? So these are the few questions which business would be interested in analyzing. Obviously, there are a lot of things which analytics can do, and we'll answer those questions as we get into the topics and handle case by case each of these cases. Now, why is there a growing need for analytics? Were we not accessing data before this? No, we were accessing that, but we had some issues. Issues were we couldn't store data. Today, we don't have a problem about storing data. We don't have a problem about platforms to handle this kind of data, and that is why you're storing more. Just think about 10 years back, if you would have had gone to any IT store to purchase a pen drive, right, a flash drive basically, the size of that would have been how much? I don't think it would have been more than 1 GB. Right, and that too would have been at a premium cost. Today, 32 GB would be a normal storage size, and imagine an enterprise what size of storage it would be having. And obviously, we are not removing data, we are retaining data, and that is why now you're thinking, if I have so much of data, what can I do about it? And that is where analytics comes into picture, right? So it's access to better tools and technologies which helps us manage more data, and in turn starts that ticking in our brain as to what can we do about it. That's why analytics. Now, when it comes to analytics, there are a lot of tools. We have SAS, we have R, we have SPSS, we have RapidMiner. We have so many things. Like I can count, like if you go on counting, it's more than 100 tools. Then why R? First of all, cost of ownership. It's something which has come out of the open source platform. R is basically a crowdsourced platform. That means you, I, and anybody who is working on it develops some package and he uploads it. A moderator will moderate it, and when it is good to use, it is available for the whole world. Obviously, such a platform which is developed by everybody will be very big. The kind of applications it would have would be immense, right? And the cost, nil. There is no cost of the software. Versatility, it's the only software which can handle multiple platforms. You can run it on a Mac, you can work it on a Windows platform, you can use it for a bank, you can use it for a telecom company, for a retail application. So the domain is also very versatile, and you can customize it because you have access to the source codes, and that is why we go for R. Most of the data scientists today, roughly more than 51%, use R, and if you want to really see how many of them use SAS, it would be less than 0.5%. That's how you should think of the scale. Moving next, we also think about why we would be using only R and not some application like SPSS, which is also available and somewhere sitting between R and SAS. Sitting somewhere between R and SAS. We do that because you would always look at two of the extreme corners, either from the cost perspective or from the usability perspective. So SAS has some advantages, R has some advantages. Looking at the cost aspect, R is the winner, and so we use R. Now, talking about different aspects, R resources are usually one of the highest paid IT resource. This is what has come out of the DICE survey that was done in Jan 2014, and obviously if you see, now it is more than that. Most of the languages used today are based on SQL when it comes to extraction. Furthermore, when you have to express that in terms of a model equation, you would be mostly using R. Many of the meant uses of analytics are not easily done with SAS. R can do it. Just a small point. You don't have a restriction in R in terms of the number of columns. You have a restriction in SAS, right? So that's how you would think of it. Now, in terms of companies which are using it, Facebook, Google, FDA, all of them are using R, and not from today. They have been using it from quite some time. In fact, if you would go back and try to think, even some of the big telecom companies in US have been using it from quite some time, and that's why we do this program in R. Now, installation of the Revolution R open software, we'll be talking about that. So basically, Revolution R is a flavor, right? So something like, if you talk about Android phones, right? So if you're looking at the platform or operating system, so you have something like a vanilla flavor, right? Then you have these other flavors which come on that, right? So you have Android version, this, and so on. So RevoR is something like that if you want to think on parallel terms. So it's basically an adaptation of your base R source code, which is done in a module based environment, so that for typical environment like maybe telecom, maybe retail, they have developed a little bit of graphical user interface which helps the user without actually going too much into the depth to analyze the data. So that's about RevoR. Right now this company has been overtaken by Microsoft, so it stands as a software which is given by Microsoft. So this has some key features. So the present version 8.0.1 is based on the R 3.1.2 version. If you look at the actual R version which is in the market, it is 3.2. That's the current version, because R is getting upgraded very fast, so the current version is about 3.2. Now the basic system requirements. Now this what we are talking about is for basically for RevoR. We'll get to what would be the basic system requirements about core R in few moments. The operating system would be Windows 7.1 minimum, 7.0 minimum, sorry, and 8.0 and above. In the server environment, it would be the 2008 R2, and the Mac version, it would be 10.9 and above. And if you're looking at something like a Linux system, it would be CentOS, which is the open source free version. Red Hat Enterprise version would be 5.8 and above, and if you're talking about Ubuntu, it would be 12.04 and above. From the processor perspective, it would be 64-bit processor with x86 compatibility architecture. And now from the hard disk aspect, it would be a 250 MB requirement, and the RAM would be 1 GB required. Recommended would be 2 GB. Now let's talk about basic R. Basic R can be operated on any of the Windows platform. So you have separate applications for Windows and the server platform. The recommended processor would be 64-bit, but you can operate it on the 32-bit version also. The RAM size is one of the key things which you are looking at, basic R, which would roughly stand at around 2 GB. That's good to use because R would be doing in-memory processing, right? It's good if you have more RAM. Now we'll talk about the installation of the RStudio. Now what is RStudio? RStudio is basically an IDE, that is an integrated development environment, which lets you collaborate on your project. So at one point in time, not one single person would be working on a project. So many people would be simultaneously collaborating, and this is the platform which lets you do that. Simultaneously, it makes it easy for us to extract data, look at graphics and all those things, and that is why we would be using RStudio. So your base R would be something which will be actually processing everything. RStudio is going to be a layer above that, which is going to talk to R. So you're not going to interact directly with R, you're going to install R, your RStudio will interact with R, and you as a user will be talking to RStudio, right? So the installation for that would be very simple. You will just go, or first thing which you need to install is your basic R. So for that you would be going on your CRAN server. Basically CRAN is your comprehensive R archive network, which you can just Google around. So just type CRAN, and that's where you will reach your CRAN website, wherein you will have separate installation files for the Windows platform as well as the Mac version, and for the Linux platform it would be a separate exe. So you'll run that first. So it's a very small executable file which you will need to download first and then run it. Once you do that, it will start running in your system, but we won't run that. Then you would be installing RStudio. For that you will just put RStudio, Google it on your Mozilla or your Google enabled frame, and once you do that you will be going on an RStudio web page wherein you can just download the executable and run it, and that is where your RStudio will be installed. Now as I was talking, there are different versions. So you have a desktop version of RStudio, which you should typically be installing if you are a learner. If you are somewhere in an environment like an enterprise, you will be using the RStudio, which is for the enterprise. Again, there are different versions in that. One is a payable version which has support along with that, and one is the free to use version, wherein obviously nobody would be supporting you if you raise a query. For example, if something crashes, whom would you look up, right? So that comes with the support part. For that you will have to pay, right? So that's a separate version. Now we'll try to understand the basic construct of RStudio as to what the different panes stand for. Basically RStudio would look like, when you first open it, so you will only see 3 windows, right? So currently what you're seeing on the screen, you're seeing 4 windows, right? So the top left quadrant is basically the script window or the data window, right? Here you would be seeing most of your codes, and if you try to open any data frame or any table in RStudio, that should also open on this same window. So this helps you to write the code, document them, and reuse them whenever you want to. Now what you're seeing on the screen is the basic menu. So if you go on file, new file, that's the RScript menu. If you do that, that's where your top left quadrant will come up, wherein you will be typing your codes and seeing your data also most of the time. Here you can run your R commands and see what actually happens. Now there are different ways of doing them. So you can just keep your cursor on the actual line which you want to execute and press a Control Enter, and it will get executed in the console window. You can just select a patch of code so that you can do a batch processing and press a Control Enter. And if you are not good with the keyboard, you can use the Run button which is shown on the screen, which does the same job. Okay, now we are talking about the environment window. So this is on the top right corner, right? So you can see that marked over there, it's the environment. So it basically lists out all the objects, data, functions, user defined functions, whatever you have created and called for in this window. So you can see whichever objects is loaded. Basically in a nutshell, you can also say that this is your RAM which you're accessing, right? On the next tab, just next to the environment, is the history. So whatever codes you're executing will be stored over here by default. Right? You can change these settings by going in the global options, wherein you can change the setting so as the history is not recorded. Right? So same like what you can do in your Google enabled web browsers, wherein you can deactivate your history, but it's recommended that you keep it activated. So in case if you are not saving anything, you can go back and revert. Now we are talking about the console window. So what you're seeing on the screen is just an blasting of the console window. So here all your commands are actually getting executed. So whatever commands you execute from your script window is actually executed in the console. So this is where you're actually accessing your R, the base R. Now what we are seeing over here is the bottom right quadrant. So you have the first tab as the file, then the plot, then the packages, then the help and the viewer. So we'll be talking about the first option, that is the file option. So it basically lists whatever files are there in your base folder. So you have a set working directory. So once you set that, this starts pointing to that folder location and will list out all the files kept over there. If you were writing something back on your hard disk, this is the exact location where it will get registered. The next tab is the package tab after the plot. So before that, after the file, there is the plot. Basically, it's the default graph device wherein you will be seeing all the graphs, and just next to that you will be having the package tabs wherein you will be seeing the base default packages listed, right? So if you're using this for the first time, you would be seeing a short list of packages. As you become an avid R user and you'll install more packages, this will get complicated and there will be more packages listed over here. The next tab which we are talking about is the plots tab, so which I had briefly described, which actually shows you the graphs. Whatever you're going to run in your console, it will show the output of the graph over here. So you're just seeing an example of a scatter plot over here. And now we are going to the setting options. So if you see on this, you can access this to tools options, and that is where you get this option. So you can do your general settings over here. For instance, you can set what would you like as your default CRAN replica mirror. So you have different locations. So like for example, in India, it would be IIT Madras, wherein you have the R server, the CRAN server. And similarly, you have one in Canada and US and different locations. You can set this to global option 0. That means it will be on the cloud. So you don't have to think about what the location is. Setting your working directory, this is the next thing we'll be doing. So to do that, you have to just use in your R, either in the script window or maybe in your console. So whenever you execute a code in your console, you'll be using directly the control button to execute a code. That's the only difference. But it's advisable to write all your codes in your script window so that it's documented. So set WD, that means set working directory, is actually like setting up where do you want all your basic folders and files to be written, right? You would also observe one strange aspect, that the slash over here, right? The slash is either has to be forward or a backward. Now, depending upon the version which you're using, so the current version it's okay, but for the old versions, maybe you will have to follow an opposite way of writing the slash. So normally you write a forward slash, you might have to use the backward slash also, depending upon the version you're using. Now, installing and using packages, right? I spoke about some default packages which are present in base R, right? Apart from that, you will be using most of the packages which run up to the scale of more than 5,000 listed on CRAN, which you might use as and when you require, right? For this, you can either go by the menu-driven option, or you can directly write the code in your console. So if you type install.packages and list the package name. So for example, if I have to use a package called as AMAP, we are not talking about what AMAP is, but supposingly if you want to use AMAP, or as it is listed over here, SQLDF, that means SQL data frames. If you have to use the functionality which is present in this package, you will just type install.packages and SQLDF or AMAP or any package which you want to install, and just press enter if you are in the console window, and if you are in the script window, you will just press control enter, and that would start installing the package. Installing and using packages. So as we were talking, if you have to use a package, obviously you need to know the functionality of a function, which package that function is actually kept. That is where you can actually use it. So supposedly you don't have any idea as to where the functionality median exists, right? Now median is something which exists in the base one, right? So to know more about that function, all you need to do is put a question mark and say median, and that will pop up a help file on the bottom right quadrant of your RStudio. That is the help file. So you should be getting how the function is used, what are the parameters which are passed over there, what are the default values present in the function, and if you want to change that, what are the options available within that. That's how it will help you. Apparently you can also use the help function, right? It stands as a separate function. So if we say just small in small alphabets help, and I'm saying small alphabet specifically because R is very case sensitive. If you type a capital help, it won't work, right? So that's why you have to type a small help, HELP, and then the function name. So if it is mean, median, whatever you want to type, you will push it over there, and that's how R will help you to understand that function. Now, if you want to understand, like I was talking about the parameters which are kept in a function, obviously function has various attributes. So I can have a function which has only one parameter, I can have a function which has 100 parameters, I can have a function which has some default parameters, which means already the parameter is tuned, right? If you want to change it, you have an option. So what are the different options available? That means the arguments. You can just use this function args and type the function name, and it will give you a list of all the arguments present within that. Incidentally, if you want to use some more help, like you want to get into the documentation of R, so you can use help.search and type the parameter which you want to search. Obviously there is one more shortcut for that with a double question mark, and you can say median. What is the difference between a single question mark and a double question mark? When you're doing a single question mark, that means it is just checking on the headers of the help file. When you're doing a double question mark search, it means it is going in the documentation, the text. Now we'll talk about the installation of packages and libraries in RStudio. So some of the basic packages which we would like to use and should be there for us to access. So that's how we will quote that. So one of the very good packages would be ggplot2, right? So it's a graphic device, right? So in R you have one base graphic device, right? That's what you have, the standard output. Then you have something which is called as lattice, and then there is something which is called as ggplot2, right? So if you want to install that and play your hands on some good nice graphics, this is the package which you would be using, and that is the install.packages ggplot2. Install.packages plyr, and there is other options to this like dplyr. Now these are packages. So plyr package is basically used to manipulate a table. So there is something of a notion called as tidy table. So if a table is not good, right, so that means it has something which is called as redundancy, same data repeated at different places, same data repeated at different data frames, right, that you need to get it sorted. So plyr package, dplyr package are the best package to do that. So that comes with that. Install.packages Reshape2 helps you change the shape of a table or a data frame. For example, if you want to transpose a data, if you want to do some manipulation like aggregations, and you want to do a group by data, then Reshape packages will let you access some of the functionalities. So one of the few functionalities in Reshape would be something like a melt and a cast operator, right? So these are two functions separate. Now what does melt mean? I want to melt my data first, and cast means once I melt that, I want to put it in the shape of something else, right? So that would be accessible only if I have this Reshape2 package. Then we are talking about the install.packages with SQLDF. SQLDF lets you access a data frame by writing codes in the form of an SQL statement, right? So you can access a data frame as if you're trying to write SQL codes, and that is what SQLDF is all about. Install.packages party lets you access some of the key functionalities like using a decision tree, right? So these has some of the functions available over there. And HMISE package, basically miscellaneous package, helps you go beyond using functionalities like summaries, structures and all those things, wherein you can look at the data with some more retrospective, right? So this is also a good package which you could use. So you can point basically to a global reference like a 0 on your global settings, which helps you access the cloud CRAN mirror. Now if you want to know anything about R, Google is the best page to do that. So you have a lot of web pages which let you understand what are your problems. So if you're trying to fire a code and there comes an error, so you can just copy paste that error and put it on Google, and Google will help you. There is a dedicated Google for R, which is rseek.org, which just talks about R codes only and the functionalities. So you can use this also, which should be handy for you. Now, as we spoke about the top eight packages which we saw in the installation phase, we'll get to know a little bit more about that in detail. So that's the 8 top packages you should be knowing. So the first and foremost, as I was talking, was SQLDF, right? So people who come from a SaaS background are typically used to writing codes in SQLs, right? So typically cleaning data, accessing data, everything is about SQL over there. So if you are from that genre, you perhaps would like to use SQLDF to access your data frames. Obviously, data frame can be easily accessed if you have a little bit of exposure to C programming, or when you go through our program in detail. So we teach you from all perspectives, SQL, from C perspective and everything. So this package SQLDF accesses a data frame with the perspective of an SQL programming. The second best package to be used is Forecast, which helps you to access packages like Arima, packages like Garch and all those things. So these functionalities are basically present in Forecast, and this is typically used when you're trying to access data which is time varying. For example, your stock market data, your sales data, wherein you try to understand what is the data in which form, whether it is stationary, non-stationary, and then try to use some forecasting models. That's where this package would be useful to us. The third important package is PLYR, and obviously there is an upgraded package for this, which is the dplyr package, which talks about how do you tidy up your data. So how do you do a transpose, how would you move a data from one form to another form. So this package is all about that. The string-R functionality is something which helps you to manipulate text data. So if supposingly you have something like a comma which you want to remove in a text, right? So for example, when you're doing sentiment analysis, you would want all your data wherein you might want to remove some punctuation marks, you would want to remove a full stop, right? Stop words and all those things. So this string-R package gives you access to all those functionalities over there. Now the fifth important aspect is about the database driver. So R can connect to any of the databases, maybe Greenplum, Oracle, PLSQL, you name it, you have it, right? So all these packages are there, but the only thing is that you will have to install those respective packages. For example, if you have to make your R to talk to an Oracle database, you will have to install an R Oracle package. If you want it to talk to a MySQL package, right, which comes from Microsoft, then you will have to install that specific package. If you want to access a MongoDB database, then you will have to install R MongoDB package. So each of these packages has the functionality which lets you communicate with those databases specifically. So that's how we will do it. So we are not listing which is the very specific package, which actually means that there are whole host of packages which according to your requirement you will have to use. The Lubridate package accesses those functionality which are used for manipulations of date. Date would be usually useful in conjunction with your Forecast package, because in Forecast you will be accessing some of the packages which are useful for time series forecasting. So wherein time and date becomes an important aspect, and obviously if you have to handle that, you will have to use this package. The ggplot2 helps you access the functionality of both lattice device as well as the base device. Now for this you need to go a little bit back. What is the difference between the base R graphic device? It's something like a standard artist. How does an artist paint? He first gives a coat, right? Something like what you're seeing on the background, a cream color coat, right? That's the first shade which you put on the pastels. You let it dry and then you put your picture with a sketch, and then you keep on doing that again and again with layers and layers. That is your base graph device which is available in R. The second one is lattice, which does a one-step execution all at one time. So what happens in base R, you will write one at a time on the graphic device. In lattice, you write all at one time, but the disadvantage with lattice is once you write, you cannot correct it. But ggplot gives you the strength of lattice as well as the strength of graph which is available in the base package. So it combines both the lattice and the base, and that is what is ggplot2. So we'll be installing that also. And then there is Reshape 2, which gives you access to manipulation of tables, data frames, matrices in R. So SQLDF, that's where you're going to access using SQL format of querying to access your data frames. So that's what we discussed. For people from SaaS, it becomes very easy to extract data and manipulate it in a data frame. So like the library forecast, which helps you access time series forecasting, ARMA models, autoregressive models, moving average models. All of these functionalities will be available in the forecast package. For example, if you were doing some analysis of a time series data, if you want to understand whether the data is stationary, which basically means whether the mean value of the data and the variance of the data is stationary or whether it's very random, right? You have different functionalities which will help you access that and isolate that aspect, and accordingly you can make a choice as to which package and which functionality you will use, whether you will use the autoregressive process or the moving average process, or you would use the autoregressive integrated moving average process. It depends on how the data turns up, and for that forecast is very good. The PLYR basically helps you just keep on changing the shape of the data, right? So if you want to use something which is in the form of a column and then you want to aggregate basis one of the column, you can use that very handily with the PLYR package and the dplyr package. The string R basically helps you replace some text, some strings in your text data, usually used in conjunction with sentiment analysis and text analytics, right? Helps you to isolate some unwanted stuff, remove them, and put some things which you want, like concatenation and all those things, and that is what string R package is all about. And from the database perspective, as we were talking, you have installed our packages. Our PostgreSQL lets you talk to any of the databases which uses basically Postgre. For example, Greenplum is based on Postgre. It's an adaptation of Postgre. So obviously you'll be using this for talking to a Greenplum database. If you're using a Microsoft database, you will be using our MySQL package. If you're talking to MongoDB, you will be using this package called as rmongo. If you would be talking to Oracle, you would be using rOracle. If you're using any generic version, you would be using RODBC. So it will be creating a connection first and then talking to that. If you're using Microsoft Lite SQL version, you'll be using RSQL Lite. The lubricate package, as we were talking, talks more about the date, right? For example, when you're using time series model, you might have to start from a very granular data like daily sales. You might want to look at this data from the perspective of monthly sales or from the perspective of weekly sales, right? Now, if the data is in the format of a date, right, you can convert it into number also, but then again what happens, you might lose that form. So you might typically want to retain the date form and still do the manipulation. If you want to do a computation like difference between two dates and all those things, those functionalities are present within the lubricate package, and that's where we will be using these packages. Sometimes even to convert the form also, like for example, if it's a US form of data. So in US maybe the month is written first and then the date might be second. In India you write the date first and the month comes second. So you can do all this manipulation with the lubricate package. The ggplot, as we were talking, is one of the most favored package in terms of graphics, right? And it's extremely useful. But perhaps you need to work with the base graphic device first, and then you would be jumping into this aspect. And then we talk about the Reshape package, which basically helps us manipulate data in terms of the table form. So mostly used in conjunction with data frames. That's where it is used. And all of these packages are together used somewhere. The functionalities of one would be used in conjunction with some other package. And this is one adaptation of the Reshape package. Now we'll be talking about data mining and graphics using graphical interface in R, right? So there are some matured and some not so matured aspects of this. We'll talk about that. So data mining graphical user interface in R. So there are many of them. A few of them which is not listed over here would be something like an R commander, right? But it won't have very great graphics. The Rattle is one such version which is quite enhanced. It's quite mature, and so we are talking about that. Apart from that, you have a host of other packages, like you have Liquid, you have so many other packages, but we'll be talking about Rattle right now. So Rattle is the R analytical tool to learn easily. That's what is the acronym, and that's why we say Rattle. So once you install this packages using install.packages Rattle, it should take around roughly 15 to 20 minutes at a strong bandwidth for you to install this whole thing. And then you will just call this with the library Rattle, and to use Rattle package you will just type Rattle on your console and press an enter, and that's where a separate window will open up. So you will have your RStudio running, and parallelly you will have your Rattle. One advantage of R Commander when you're using it as a graphical user interface is that R Commander would create the objects within your RStudio or your base R, whereas Rattle will not write these objects in your base R or your RStudio. So whatever you're creating over here just remains over here. You cannot access these objects in your base R or RStudio. So one caution. Okay, Rattle presents a host of menu-driven functionalities wherein you don't have to write the codes. You can just use a click approach, right? And the base editable version of this software comes from rattletoggaware.com. Those are the developers, and then they have listed this on the CRAN, right? So you can download this from CRAN. The next graphic device in R is the deducer. Now this talks about more about a Java based interface, right? So this is basically developed with the Java interface, right? And this is standing as an alternative to your proprietary data analysis softwares like SPSS, JPM and Minitab, right? Menu driven system to do the same data analysis manipulation task. Has an Excel like spreadsheet which helps us view the data and edit the data. And it's designed to be used in conjunction with a Java based environment, right? So you would require the latest Java console for the same. Graphical user interface in R, right? So when you're talking about, मेरे को दिखाई नहीं दे रहा स्क्रीन में है क्या, मतलब क्या है इसमें, डिड्यूसर का है किसका है, अच्छा डिड्यूसर का है, ओके. So we are talking right now about the graphical user interface in R, in that we are talking about the deducer. So if you are using an interface like deducer, this is what you will like. You will get components wherein you can have a drag and drop approach for graphics. So you can just extract the data on your Excel based sheet, right? So deducer has an Excel like grid wherein you can just extract the data, and then you can use any of these image based attributes. So if you want a histogram, you can just click over there and drag it, and accordingly it will create a histogram, right? So it becomes very easy for a user to use these kinds of tools. And now some fun with R. So if you want to learn R a little bit on your own at your own pace later on, you can use a SOAL package. Now SOAL is a package which is basically used by instructors and by students. So the instructors basically develop some kind of a tutorial and they load it as a lesson, and SOAL basically helps you to use it as a tutorial. So this will open up within RStudio. You just have to say install.packages SOAL, and then you have some options like install from SOAL, and then you will type the name of the lesson you want to learn. So some of these would be like R_training_alt, right? So if you want to get a complete list, you can go on the website. Say for example, you can just do a Google wherein you can say SOAL lessons, and it will point to a website wherein you would be able to download these lessons. So once you do that, you will be able to play around with this. So it's just basically a window function which is used, wherein the user is just giving inputs basis the questions which are asked on a screen, right? So it won't be a voice interactive tutorial, it will be a text interactive tutorial. So you can use that.